Hello everyone, myself Mrs. Shailaja Doddi, Assistant Professor, Civil Engineering Department, Walchand Institute of Technology, Solapur. In today's lecture, we are going to study about the engineering mechanics. So in this lecture, I will introduce you the basic concept or basic terminologies which are used in the engineering mechanics and the classification of the engineering mechanics. The mechanics is classified in two types. One is mechanics of solids and another is mechanics of fluids. In mechanics of fluids, we will study about the ideal fluid, viscous fluid and incompressible fluid. In mechanics of solids, we are going to study the mechanics of the rigid bodies, mechanics of the deformed bodies. This mechanics of rigid bodies further classified as in statics and dynamics. So in this engineering mechanics, we are going to study about the mechanics of the rigid bodies. Again, this dynamics is further classified as the kinematics and the kinetics. The static is the study of effect of the force system acting on a particle or the rigid body when the body is at the rest condition. Then dynamics is nothing but the study of effect of the forces acting on a particle or a rigid body when the body is in motion. This dynamics is further classified as the kinematics and kinetics. What is meant by kinematics? It is the study of geometry of the motion without reference to the cause of motion, and the kinetics is the study of geometry of motion with reference to the cause of motion. What it means in kinematics, the mass and force causing motion are not considered into the account, and in kinetics we will consider the mass as well as the force causing motion in the kinetics. Now these are some basic terminologies used in the engineering mechanics. Mass, it is quantity of matter possessed by a body. The unit of mass is kg. The next one is time. Time is the measure of the succession of the events, which is measured in the seconds. Then space, the geometric region in which the study of body is involved. Next one is length. So it is the concept of measuring the linear distances. The length is measured in meters, kilometers. Okay. The next one is displacement. It is the distance travelled by the body or the particle in the specified direction. The next one is the velocity. It is the rate of change of displacement with respect to the time. The unit of velocity is meter per second. Then acceleration, it is the rate of change of velocity with respect to the time, and it measures in meter per second square. Next one is momentum. The product of mass and velocity is called as the momentum, and it is measured in terms of kg meter per second. Then what is meant by rigid body? It is the relative position of any two particles in the body will not change under the action of the force. The particle has an object which has only mass, no particular size. Now, in engineering mechanics, we are having the terms like mass, length, time, force, velocity is there, acceleration is there. So these all quantities are classified as a scalar quantities as well as the vector quantities. So what is meant by scalar quantity? The quantities which are having only magnitude, no direction. Those are called as the scalar quantities. The example is length, mass and time. If vector quantity, so in this we can consider the mass as well as the direction of the unit. So if you consider the force is expressed in terms of mass and direction. For example, now these are the basic laws used in the engineering mechanics, or Newton's first law. It states that every body continues in a state of rest or in a uniform motion unless until it is acted by any external agency. Okay. Newton's second law, it states that the rate of change of momentum of body is directly proportional to the impressed force, and it takes place in the direction of the force in which it is acting. So we can, in Newton's third law, it said that at every action there is equal and opposite reaction. So, we can say here that is F is equal to R. F is the applied force and R will be the reaction on the particular body. Then Newton's law of gravitation. Force of attraction between any two bodies is directly proportional to their masses and inversely proportional to the square of the distance between those two bodies. So, law of transmissibility of forces. What it said that the condition of equilibrium or uniform motion of rigid body will remain unchanged if the point of application of the force acting on a body is transmitted to act at any other point along its line of action. For example, it is the rigid body where this force is acting at this point A in the line of action towards the point C. Okay. It is the line of action of the force. If I replace this force at any other point on the body, so here you can see I have replaced this force from point A to point B, but in the same line of action at the point A, isn't it? So, the effect of this force on the body is remain unchanged. So, whenever we can apply this force in the same direction and with the same magnitude, the body remains unchanged. Then next one is law of parallelogram of forces. When the two forces are acting at a point, okay, with an angle theta, the resultant is the force which will give the same effect by the two forces. Okay. So, here you can see if two forces acting simultaneously on a body at a point are represented in magnitude and direction. So, here you can see this P and Q are the magnitude of the forces and this arrow shows the direction of this force P and the direction of the force Q. By the two adjacent sides of the parallelogram, then the resultant is represented in magnitude and direction by the diagonal of the parallelogram. So, here you can see this R is nothing but the magnitude of the resultant force and this arrow will indicate the direction of the resultant force. In here we can say the effect of the force P and Q is replaced by a single force that is called as the resultant force, which will give the same effect on the body. So, here we can derive the equation for the magnitude of the resultant force. Okay. So, we will get the equation R is equal to under root P square plus Q square plus 2 PQ cos theta. It will be the magnitude of the resultant force and the direction we can measure or we can calculate by using tan alpha is equal to Q sin theta plus P plus Q cos theta. Then force is defined as the external agency which is tied to change the state of rest or uniform motion of a body. The unit of force is Newton. So, here I will express this 100 Newton force is acting at point C, which is 2 meter away from the point A, and it is acting towards the downward movement. It is the rotational effect caused by a force on a body is called a moment or moment of force. Okay. It is expressed in terms of force into perpendicular distance. The unit of moment is Newton meter. Okay. Here this force is acting towards the downward. What is meant by rotational effect? If I rotate this force about this central point, okay, so what it happen? So, it will rotate about this point in the clockwise direction. Okay. So, the moment will have two directions, one is clockwise direction and another one is anti-clockwise direction. Here this force F is acting towards the down, and if I take the rotational effect about this point, so it will give the clockwise movement. And we will consider the clockwise movement as the positive movement. Then in this figure, here you can see this force is again acting towards the downward, but the point or axis of the rotation is at the opposite side. Okay, so if I rotate this force, or if I take the rotational effect of this force about this central point, it will rotate in the anti-clockwise direction. So here you can see it is rotate in the anti-clockwise direction. So here we can call it as the anti-clockwise movement. So we will consider anti-clockwise movement as the negative movement. So here you can see the moment is equal to force into perpendicular distance. It should not only the distance, it should be always perpendicular distance to the moment center. So this point is called as the moment center. Then next one is the couple. What is mean by couple? The two equal forces in magnitude but are acting in opposite direction and separated by the definite distance are said to form a couple. So couple is measured in terms of force into distance. For example, if you consider this force F, it is acting towards downward. Okay, so when I apply the same force in the magnitude but in opposite direction, so if you consider here, this force is acting towards the downward and here it is acting towards the upward. So this type of forces means same in magnitude, opposite in direction, but these are separated by the definite distance. So here x is the distance between these two forces. So these type of forces can able to form a couple. Okay. Now these are some questions which are asked on the basis of this video. These are the answers. These are the references considered for the study. Thank you.